Kevin O'Toole.
And I'm Jesse Tantio, however that's upside down. So basically we're having a project today about paper lanterns. So paper lanterns are basically very thin tissue paper, and it is folded in a box shape, and you'll have a wire underneath that will be lit, and that it will be lit by a fire, which will then burn the oxygen within it, and then have the lantern lift up and fly into the air. So that lantern itself exerts a certain force of, I guess it's calculated 0.3 newtons, as we calculated earlier, in order for it to lift off. And so we actually want to prevent it from lifting off in a way that we can control when we want the lantern to be released. So we have a motor here that is exerting a torque of 0.3 newtons. And so when some force greater than 0.3 newtons, for example, when the lantern is being lit and it wants to fly away, is greater than that amount, then the LED itself will actually turn off. So that is an indicator that the lantern is ready to be lifted off. And right now there is a force preventing the lantern from lifting off. And in order to release the lantern, we have another separate photodiode that is not currently with us, which is basically an internal on and off. It has an internal on and off switch, and that photodiode reads light intensity. So we actually have the sonic screwdriver, and it emits kind of like Kevin.
Ultraviolet light.
Ultraviolet, so UV. And so we want to see, once the photodiode detects the light intensity of the UV rays, then it will flick on the switch, as you can say, and it will allow it to put in a voltage that we have right there of a certain speed, and that will actually release the lantern by turning on the motor in the direction that the string will unravel the lantern and let it free. So, onto the circuit itself.
Okay, so this is the circuit that we built in order to accomplish these tasks. The general layout of the circuit, these 4 op-amps here, are all pretty much from what we have done in Lab 11 in order to make our motor behave as a spring. And we wanted the motor to behave as a spring just because we wanted it to be able to maintain the lantern at a certain height as it's exerting that constant force. Some things that we tweaked about the circuit, this resistor here affects the K constant of the spring. We had to up that a lot in order for it to produce the right amount of force without letting the lantern a lot higher. So the amount that you have to pull the string is very short because we increased the value of that resistor. Another thing we had adjusted is we're now reading the torque that is being put out. As the spring puts back the torque, in order to create that feedback loop, in order to have the spring-like behavior, it has to put a voltage into here. We read that voltage, and using an op-amp, we are able to see whether it is greater than or less than some threshold voltage. We made this threshold voltage just by making a ratio of these 2 resistors between 12 volts and ground to create whatever voltage we want between 0 and 12 volts. We calculated this so that the threshold torque that is needed is exactly 0.3 newtons pulling up on the end of that wheel, and that will cause the light to turn off. Another thing we have added is the sonic screwdriver control. We do not have the circuit board which controls the photodiode right now because it uses an Arduino, and that is currently being used by a fellow student. But our voltage input is essentially in that circuit board going to be 5 volts when we are above the light threshold on the photodiode, and it's going to be 0 volts when we are below it. This voltage goes in across this resistor. The resistor changes basically the amount of voltage which will end up in the adder over here. It's basically a proportional gain on that, so we can adjust the speed very nicely. And so when that V in is 5 volts, it'll add a constant voltage here. what will happen to that voltage is it will be added to VMF to become VEMF plus V speed. It will then get integrated into what the motor thinks theta is. And so there's going to be a constant theta that's kind of rotating around, and the motor will use its springiness to go into that constantly rotating motion rather than the still motion. So simply by adding a voltage there, we were able to go from a still motor to a spinning motor, and that spinning is at a nice rate, which will allow us to release the lantern. And that's about it. We can sort of show to you the lantern releasing. If we have the string right here, all we have to do is hook it up to some constant voltage, and it will allow the lantern to float off into the sky.
Aww.
And that's our presentation.
Yay!